So electromagnetic effect question 14. Current carrying wire is placed between the poles of a U-shaped magnet, as you can see here. 3.2 is the spacing between the two magnetic poles. Determine the magnitude of the force on the wire due to a magnetic field. You may assume that the field is uniform. The current is 820 milliampere. The length of a wire is 6.9, and the magnetic flux density is 0.074. So this length of a wire, that is 6.9 centimeter. So to get the force on the wire, we use a formula F is equals to BIL sine theta. We have the strength, we have B. We know the current 820 milliampere, we can convert. We know the length of wire. But there's another thing, the angle. You don't know this angle. Like we need the angle between the magnetic pole and we need the angle between the magnetic field and the length. So how we can work out this? Because we always take a perpendicular component. So if I take, either you can divide so I need this length. Or I can also draw a line to show the magnetic field. So magnetic field is pointing in this way. Magnetic field is pointing in this way from north to south. So I need the angle between the magnetic field and the wire. So which angle, according to this, any of the side you can take, like if I just take one of them, I need this angle because we need the angle between the magnetic field and the wire. So this is making a right angle triangle. If this is making a right angle triangle, I have the hypotenuse and I have the base as well, because the angle is between the base and the hypotenuse. So if I have the base and I have the hypotenuse, so which relation I will use? I'll use cosine theta. So cosine theta is base over hypotenuse. So if I need theta, so it will be base. What is the base here? This is the hypotenuse. This is a 90-degree angle is there. So this is the hypotenuse. Here is a base. So base is 3.2. We don't, when you're taking a trigonometric ratio, no need for unit conversion. Like if you use in centimeter and take a ratio, that will give us the same result. So what is the value for the theta here when you take a cosine inverse other side? So theta is equals to cosine inverse 3.2 over 6.9. So we'll get the theta, that is, what's the theta here? Okay, 62.4. So 62.4 degrees. Then we use the formula that F is equals to BIL. So we have the B, which is 0.074 Tesla. We know the length of a wire, that is 0.069 because it was in centimeter. This is the length. I put the current here. This is the length, and then the current is 820 milliampere. So 820 into 10 power -3 times the sine, and the angle between them is what? It is 62.4. So 62.4. Just substitute all these values. That will give us the value for the force, which is 0.004. Okay. Yeah, 3.7 into 10 power -3. So, or I can also say 0.0037 Newton. That's the force which it experienced. The next is, so we always take the angle between the length of a section of a wire and the magnetic field. If there were n turn, like example, if there not a single wire, there multiple turns are there, so then that length will be multiplied by the number of the turns. Explain the direction of the force on the wire. How to work out the direction of the force? So you have to use, because current is there passing through a wire. So which rule we have to use? We have to use a Fleming's left hand rule. Because there's a current passing through a wire. So we use a Fleming's left hand rule. So according to Fleming's left hand rule, your index finger represents the magnetic field. So it should point in this. Use your left hand, your index finger pointing in the magnetic field. Your second finger represent the direction of the current, which is going in this way. So index finger is pointing from north to south. Your second finger shows the direction of the current. Where your thumb is pointing, that is the direction of the force. So where our thumb is pointing, when you apply the rule, the left hand. So using the Fleming's left hand rule, where the force is applied, like appear the direction of the force. Good. That's right. It is pointing into, so it means the force is into. So usually it's of 2 marks. So you will mention the explain the direction of the force on wire. How you write this answer in exam? You will mention that the wire is perpendicular, like a wire cuts the magnetic field perpendicular. So using a Fleming's left hand rule, we can work out the direction of the force. Is it clear? Question 14.